14th is a very valuable theoretical question. It says, what is the significance of the terms isolated gaseous atom and ground state while defining ionization enthalpy and electron gain enthalpy? And there is some hint also given, which is whatever. First of all, what is ionization energy? It is the minimum energy required to remove the most loosely bound electron from an isolated gaseous atom in its ground state to form an isolated gaseous ion in its ground state. So this energy is called ionization energy. Now they are saying, what is the significance of the term isolated gaseous atom? See, the thing is very simple. Instead of gaseous, had I had something like Na solid giving me Na plus solid plus electron, you know, this would have been photoelectric work function. Why? Light falls from solid metal, electrons are ejected, you get ions. What is this? This is clean photoelectric work function, nothing else. Oh my God. So, this is not ionization energy. As a matter of fact, if you want to convert Na plus gas, Na gas to Na plus gas, and if you just want to see the difference, watch this. Na solid to Na gas. When I'm trying to judge if these differences are the same, they're not same. This is delta H sublimation of sodium, and this is delta H, minus of delta H sublimation of Na plus. This is sublimation, this is condensation or deposition, whatever. I hope you can see that tendency of sodium atom to undergo sublimation may be very different from the tendency of sodium ions to undergo sublimation. Yes. Since these two energies are not the same, I'm going and coming back, and since this difference is not zero, do you see that photoelectric work function is like from here, if I want to go here, this is the delta H, this is the energy change, and this would be equal to delta H sublimation of sodium plus ionization energy minus delta H sublimation of Na plus. This is very dangerous, because since this is not zero, I find that both these entities, photoelectric work function and ionization energy, could very well be different. And yes, dears, indeed they are quite different. So when they say isolated gaseous atom, is the word gaseous necessary? Very necessary. Why isolated? If it is not isolated, say for example, if I have Na2 gas giving me Na plus gas plus electron. Now in this case, during ionization, I am also supposed to break Na-Na bond. That is another additional nuisance, that is extra energy. So I'll keep on getting different values. So unless I have isolated gaseous atom, I will not get a unique number. If I want a unique absolute number which is experimentally reproducible, I have to be accurate. So when I say isolated, that means only one atom you have, and gaseous and ground state also. Why ground state? Because if sodium ion also, sodium already is in excited state. Say for example, to take electron out of sodium, I need 2 electron volts. Say for example, if sodium atom becomes excited and it already is excited by say 1 electron volts of energy, I just have to supply extra 1 electron volt to take out that electron, right? That is not fair, because most of the atoms do not stay in excited state. So I have to take this also. This has to be in ground state. As a matter of fact, this also has to be in ground state. Unless I clearly define their energy levels, I cannot measure the difference between the energy levels, and the difference between the energy levels is nothing but the ionization energy of sodium. So, for accurately defining ionization energy, I must know that both reactant and product must be in ground state. Of course, they must be isolated and gaseous, and this, my dear, is the very significant portion of the definition of ionization energy. And very similarly, electron gain enthalpy also, whenever you are measuring any energy changes, if you are measuring a change between 2 points, then 2 points have to be correctly, accurately defined. And for that, isolated, gaseous, ground state are very important terms.